Sample 14 on unsteady flow. A cylindrical tank contains three liquids of specific gravities 0.8, 1.0, and 1.5. Each liquid has a thickness of 0.6 meter and the tank is 1.2 meters in diameter. If a circular orifice 100 mm in diameter and with coefficient of discharge 0.65 drains the liquid, determine the time to remove the lowest liquid, remove the second liquid to drain the tank completely. To help analyze the situation, let's draw the figure. So here is the situation. We have the lightest, of course, at the topmost, the heaviest at the lowermost. So since the liquids have different specific gravities, so we have to convert the upper liquids into the lower liquid, the one that will flow out first. And let's denote it in the figure as HI1. So HI1 is equal to, this is already 0.6, this has a specific gravity of 1.5, so there's no need to convert this. The second liquid is specific gravity times thickness divided by specific gravity of the lowermost liquid. Then the uppermost liquid is 0.8 times 0.6 divided by 1.5. So formula time equals to area S, quantity square root of HI minus square root of HF over kaotog. C area O square root of 2G because area S is constant for this case. Area S is constant. So T is 2 pi 0.6 square, quantity square root of HI minus square root of HF over 0.65 times pi 0.05 square. Radius of the orifice is 50 mm or 0.05 meter, then square root of 19.62. Cancel out pi and solving for the constant, 100.03 quantity square root of HI minus square root of HF, where HI is equal to 0.6 plus 1 times 0.6 over 1.5 plus 0.8 times 0.6 over 1.5. So that's how to convert the upper liquid into the lowermost liquid. Specific gravity of the upper liquid times thickness of the upper liquid divided by specific gravity of the lowermost liquid. So HI1 is 1.32 meters. So when the lowermost liquid is discharged out, then the final head would be 1.32 minus 0.6. 1.32 initial head 1 minus 0.6 after the lowermost liquid is removed is 0.72. So substitute here. Time is 100.03, quantity square root of 1.32 minus square root of 0.72. So the time to remove the lowermost liquid is 30.05. Then for the time to remove the second liquid, we cannot remove the second liquid by itself because the orifice is on the bottom. So therefore, it is equal to 30.05 plus time to remove the second liquid. So time to remove the second liquid is 30.05 plus time to remove the second liquid. In the second situation, the second liquid and the uppermost liquid are left. So this time, we convert the uppermost liquid into the second liquid, and that is, we have 0.6 plus 0.8 times 0.6 divided by 1 this time because the specific gravity of the second liquid is 1. I call that is HI2. So HI2 is 0.6 plus 0.8 times 0.6 over 1. So that would be 1.08 meter. When the second liquid is removed, the thickness is 0.6, so 1.08 minus 0.6. That means the final head is 0.48. 1.08 minus 0.6. Then substitute into the same formula, 100.03 square root of 1.08 minus square root of 0.48. So T2 is 34.65 seconds. So therefore, the time to remove the second liquid will take 30.05 plus 34.65. So it is 64.7 seconds. And finally, time to remove the time to drain the tank completely, we'll call that T. It is equal to 64.7 plus T3. Because in the last case, the uppermost liquid is left, there's no need to convert that. So the initial head is 0.6, the final head is 0. So T is 64.7 plus 100.03, quantity square root of 0.6 minus square root of 0. So T is 142.2 seconds. So that's it for this problem.